think we'll get started. Our first talk is by Boris Clénet. He's a research engineer at the MPen team in Rennes, France. His current work focuses on the analytical variability of fMRI pipelines and reproducibility in the context of neuroimaging. And today he's going to talk to us about extending the brain imaging data structure specification to provenance metadata. Welcome, Boris.
Integrating provenance metadata into bits. So I assume that most of you know bits, but here's some information about it. It's a standard to organize data inside datasets in the neuroimaging context. It's widely used, and it aims at steering people towards FAIR principle. Because, you know, we want data to be open, but as someone said earlier, this is not currently the reality. So besides that, BITS wants to keep things easy and easy to learn and to adopt. But what do we want provenance in bits? We want to capture the recipe that generated a data set. And we think that it's a step towards FAIR principle because it enhances the reproducibility of data sets. And of course, as it's a part of bits, we should make it simple and easy to adopt. But at the same time, we see provenance as a research tool that should be precise and flexible enough so that we can query it, analyze it, etc., etc. Here is a simple example of how we want provenance to look like. So this case is a conversion example, a conversion between file formats. We see the conversion box here. We call it an activity. And it uses some data in yellow. We call them entities. And it uses as well a software environment, here Fedora, and it's associated with software. So these are the main provenance objects we are going to deal with later. So how it works? We don't want to reinvent everything, so we use already existing tools. So we should find a place to store metadata in bits, but luckily there's already a place, and it's encoded JSON. And then we should use a common vocabulary so that everyone understands what we are describing. For that, we use W3C prov. That does exactly that. And then the nice thing about prov is that it can be easily mapped into an RDF graph that we can query, export, whatever, exchange. So now, well, to store provenance in bits, so it can be either in the description of the dataset as JSON objects. It can be in description of files. You see here the JSON file associated with each data file. And we also introduce 4 new files, new JSON files that would contain the provenance objects I described earlier. So activities, entities, software, and environment. You see the 4 files under the prov directory. And to conclude, there's a small example of the conversion graph I showed earlier. So in the content, in the activities file, we have the description of an activity. Of the conversion activity, we see that it's uniquely identified. We see that there's a command line associated to it. And we see that it's associated with the DICOM2NX software. We see that it uses some data. So the yellow dots here. So some data as input, some software environment as input as well. And yeah, and below the content of the description of a file as a JSON sidecar. And in here we see also that this file was generated by the activities that was described in the other file. And we can also have in this file some other metadata related to provenance. For example, here the checksum of the file. So that's it. Of course, it's simple, but it can apply to more complex graphs, and we hope to do great research with that. Thank you.
Okay, thank you very much. Does anyone have, and we'll just do, if anyone has a quick question? Yep. Okay.
Thanks a lot. This is very interesting. If you go back one slide, in the reference to DCM to NIX associated with,
yeah,
this looks like a random identifier. So if you run that provenance graph generation thing again, does it come out the same or different?
Actually, we are working on that because we want the identifiers to be unique.
Mm-hmm.
And we need to find a way that it's unique, but it's also reproducible. So if you have the same data as input and the same metadata as input, it should generate an identifier that is always the same.
Maybe we can have a conversation, because I think there might be a solution to that.
Of course.
Okay, one more.
There are many possible use cases of that provenance graph, but I would like to know what is your personal, focus and use case that you're thinking. Okay, I'm going to build this for that specific reason, something that I can use.
Well, we're currently working on analytic variability. So the variability on how pipelines are built to analyze data. So we think that's a way to represent pipelines and then maybe compare graphs, query graphs on certain parameters for a pipeline. Yeah, don't know if it's clear.
You want to query the provenance graph as a function of features that might impact analytical variability results.
Yeah.
Yeah. Okay. Cool.
Okay, great. Thank you very much.
You.